Okay. Calculate the partial derivatives and evaluate them at each of the indicated points. So as a reminder here, when you're taking a partial derivative with respect to x, the y is treated as a constant. So you just ignore it. Wherever you see y, you just ignore it and you just take the derivative with respect to x. So it's minus 3x to the minus 4 power, keep the y squared, plus derivative of x is 1 y squared, plus y is constant, 2x, derivative of 2x is 2y here. And then I would go ahead and do the next part just to kind of, close this part of it out, because it's really related to the one you just did. You're putting x, 1 in for x, so it's minus 3, 1 to the minus 4 power times minus 1 squared plus 1 times minus 1 squared plus 2 times minus 1. It's really easy to mess this up. So, definitely check in your calculator a couple of times. But this is 1, this minus 3, 1, so minus 3 plus 1 minus 2. This looks like it's minus 4, for example. All right, now I'm just going to go down a little bit. There's not enough space here to make this clear, but I'm going to rewrite the function here, fx comma y, x to the minus 3y squared plus xy squared plus 2xy. When you take a derivative with respect to y, you just look at the y and ignore the x. It's going to come along, but what's the derivative of y? Well, it's 2y. There's no like y primes anymore. You're beyond that. So this is x to the minus 3 times 2y plus 2y again, but that x comes down, plus the derivative of y is 1, 2x. And then you evaluate it at that point again. So it's 1 to the minus 3 power, 2 times minus 1 plus 1 times 2 times minus 1 plus 2 times 1. So this is negative 2 minus 2 plus 2. So this looks like it ends up being minus 2. And that's a pretty straightforward one here. I would definitely want you to try number 2 here, and at least trying to take the 2 derivatives. This one I believe is actually easier than the one I just did. So if you understood what I did, you should be able to do this one because the derivatives aren't as difficult. So I would just ask you to take about 60 seconds and see if you can find the first 2 derivatives, and then I'll write out the answers.
Is the first one negative 65 plus 10y plus 7y?
So the first one here, there's no, the first part of it is negative 65. There is no x here, so this is treated like a number, and its derivative is 0. Plus 7y is the derivative there.
So you don't get rid of the 10.
Yeah. So like when you do with respect to y here in the second answer, this negative 65x is treated like a number, just like 13,000 is. So it's or a constant is the right word, but its derivative is 0 for that part, and then you move on to the others.
Okay. So negative 65x plus 10.
So the derivative of for this second part here, I'm just going to rewrite it here. We'll go through it together. This is a number, so its derivative is 0. Because you're doing it with respect to y, anything with an x by itself is just treated as a number, so this is also 0. The derivative with respect to y here is just 10, because there's no x's, but just you take the derivative with respect to y, and then here the derivative of y by itself, like you look at y by itself, derivative of y is 1. Well, this other stuff just comes with it, so it's 10 plus 7x.
But I don't understand why like negative 65x goes to 0, because aren't you just supposed to leave it if it's with x?
They would be that if it was negative 65 xy, what you're saying is true. Uh, what you're so let me write this out. You can see how this is less clear. Let me just write it out again, but I'm going to write it out as if you're doing it 65x y to the 0 plus 10y x to the 0 plus 7xy. So now they all have x and y's in them. Actually, let me not do that. That's not going to be clear. Let me try again here. So 13,000. Okay, when we're doing this with respect to x, partial f partial x. Okay, you first only want to identify terms that have an x in it. X, x, and x. So everything else derivative goes to 0. There's no x here. There's no x here either. So really, both of those can go away because there's nothing there that has an x in it. You can only take a derivative or something if it has an x in it. So that's why these both go to 0. The derivative of this is treated as it always is. But here, like what you have to look at this is it's really 7y times x, and you're just taking the derivative of x, and this just comes along with it like it's a number. So it's plus 7y. The derivative of x is 1. Let's do it again for partial f partial y. So you only want to look for something that has a y in it. So no y and no y. So those are both 0. This right here, the derivative is 10. This right here you treat it as 7x times y. So the derivative of y is 1, and then 7x is just 7x times 1. We should do some more problems like this to make it clear. 4 would be good to do. And then the evaluating it is just putting the numbers into the calculator. I assume you get a calculator this time. I don't know actually. Uh, let's try number 4. Okay, so the function is given up here, and when you're doing it with respect to x, it's good to rewrite the function. So the function is negative 4 y to the 0.1 power times x to the 0.3 power. This is exactly the same as the original, but I've rewritten so that you treat this like a constant, like a number. And this is the thing you're going to take the derivative of using power rule. So if I just ask you for this on the right, what's the derivative of x to the 0.3? Well, you know to bring 0.3 out in front and subtract 1 from it. So it's 0.3x to the minus 0.7 power. And then what about all this? Well, if it's a constant, like let's just say it was 10, you would put it out in front. Well, you do the same thing here. You just bring it out in front. Were you able to follow that?
Yeah.
Okay. Now you can absolutely multiply here, but WebAssign doesn't care. But if you do multiply, it's minus 1.2 x to the minus 0.7 y to the 0.1 power. Now let's look at the function again, f of x comma y. But I'm going to do it now where we're taking derivative with respect to y. So treat negative 4x to the 0.3. That's your constant y to the 0.1 power. This is the thing you have to take the derivative of. This is just a constant or a number that just comes along for the ride. So the derivative of this is 0.1 y to the minus 0.9 power. And then you just bring this part down, negative 4x to the 0.3 times this. And if you wanted to, you can write this as minus 0.4 x to the 0.3 y to the minus 0.9.
Okay.
we should do another one like this. Five. Yeah, five is good to do. So let me again have you try and do five on your own, and just like I did do one of the earlier ones here, and see if you can calculate the derivatives here of these.
So the 2x to the negative 0.6, and then you just keep y.
Do you? Yeah, if you want to actually multiply, yeah. So I can. The first one is 2x to the minus 0.6 y to the 0.2 power.
Yeah. And the next one is 5x to the 0.4 and 0.2y to the negative 0.8.
Yes. So it ends up being when you simplify here 4x to the 0.4 y to the minus 0.8 power.
Where is the 4 from? Oh,
5 times 0.2.
oh, got it. Good.
Actually, no, that's not right. It's just 1. Sorry, it's 1. There is no 4 there.
Okay.
It's really hideous. Okay, that is somewhat clear-ish. 6 is good to do. Six is second order partial derivatives. We do have to tackle this, although this would not be the one I would like to tackle first with this. The fact that there are exponents here. Here's one like, yeah, let's go. These are related. This is 14. Um, okay, so this is like the one that we did number 2. Give this one a try and see if you can come up with the correct answer for the derivative of this.
So would it be just 4 minus 2y?
For the first one, it is definitely 4 minus 2y. That is correct.
The second one is negative 3 minus 2x.
Yes. Very good. All right. 15 is good to do next. And then we'll switch topics here, I think. That we might be wise here to do. Okay, so give this one a try. Be right back here. All right,
Okay.
I'm back here. Sorry, I was just away here.
Okay. Yeah, that's what I got. But
Great.
wait. Um. Oh, you just moved the 5. Why did you move the 5 in front?
You don't have to. You can leave it over here. It's just cleaner. WebAssign will take either, as long as you show that you're multiplying.
Okay, got it.
Um, okay, so we have a choice here. We can either move to second order derivatives and chain rule stuff here, or we can switch to the min max problems, LP problems.
Um. Wait, what was the first option?
So you're. Let me show you. I'll show you a problem, and then because to give you kind of clarity on what I'm asking for here. So 21 is a good example of what there's a couple of things that you have to be able to do. It's notice that these are second order derivatives, which means that you do exactly what we just did in the last problem, but then you have to take yet another derivative to get
Mhm.
the answer. Um,
We can
and
just
so
do one of these. Yeah.
of course, yeah, and then there's also, and then this is kind of slash. There's some chain rule questions that we haven't looked at yet either.
Okay. Sure.
Okay, so what this says right here in words would be like take the derivative with respect to x, then do it again. So the first derivative with respect to x, you already did this in the previous problem that we just did up here. Well, the numbers are slightly different, but it ends up being 9x to the 8th, y to the 5th minus 1. And so the second derivative with respect to x is you have to take the derivative of this again with respect to x. Now this time this goes away because its derivative of a constant is 0. So it's still power rule, 72x to the 7th, y to the 5th. And that is the answer here, 72x to the 7th, y to the 5th.
Okay. Okay.
Okay, so if that's clear, now we can do with respect to y. So we need to define partial f, partial y. So we're taking the derivative of this original thing with respect to y. So it's like you said, it's x to the 9th, but the derivative of y to the 5th is 5y to the 4th. The derivative of this thing over here, this minus x, is 0. But then we have to do it again. We have to find the second derivative with respect to y here. So it's this 5x to the 9th. That just comes along. And the derivative of y to the 4th is 4y cubed. So that reduces to 20x to the 9th y cubed.
Yeah. Okay.
Now your instructor probably went about at some point made some long statement about this, but these are the same.
Okay.
Meaning like what goes in each box is the same once you find it.
Okay.
So there's two choices for that. You can either go from this step here that I've circled or this step here that I've circled. So for example, if you go from this one up the top here, you then have to take the derivative of this with respect to y. Like you look at this thing and you take its derivative with respect to y. You just did it with x, now you do it with respect to y. If you do it here, you take the derivative of this with respect to x. The derivative of this thing with respect to x. So you either start with x and then do y, or start with y and then do x. It doesn't matter, you get the same result. So the derivative with respect to y here is 9x to the 8th, 5y to the 4th, just the root of that, and that reduces to 45x to the 8th, y to the 4th. This one here, you take the derivative with respect to x. So that's 9 times 5, 45x to the 8th, y to the 4th. So notice these are exactly the same.
So I'm confused what they're asking.
So what they're asking you to do is first take the derivative with respect to x, which you found here, then take the derivative with respect to y of this thing. So you
Okay.
take the result of one and use it in the next step. This one's saying first take your derivative with respect to y, and you just did that here. Then take it with respect to x, so what's left over.
Okay.
The key thing is you should settle on which one you want to do, and then know that these are exactly the same. And if you're submitting on a test, only submit one of them at a time. That way, if you're wrong, you can have a chance to fix it. And if you're right, you get them both right as a result of doing that.
Mhm.
So we should do another one here. 22 is another good one to do. If you do this review a few times, you're going to be really successful in the exam because it's going to be just like these questions, it looks like, and
Mhm.
you can follow the steps here. So this function fxy, there's really two ways you can look at it. It's 2x squared times y, okay, uh, or it's or I guess you could look at it as x squared times 2y. Um, well, maybe that's not even all that clear, but what I was trying to do is show you, like, sometimes you just look at it as a number times a variable, and then and then this is the number and this is the variable. Maybe that's not clear, but um, the derivative here with respect to x, first function, you take the derivative with respect to x. So that's where you're taking the derivative of this 2x squared, which
Yeah,
is 4x, and the y comes along.
yeah,
So when you take the derivative again with respect to x, y is a constant. It's this is really like 4y times x. So the derivative of x is 1, so this is just 4y. Okay, so now let's do it again. Let's take the derivative, but now we're going to do it with respect to y. So we're going back to the original function, and the original function, you can kind of see it as like 2x squared times y. The derivative with respect to y is 1 times 2x squared. When you take the derivative here again with respect to y, is there a y here? And there's no y's.
Mhm.
So it's basically saying, what's the derivative of a number? The derivative number is 0. Okay, now this third one here, again, this is where we kind of there's some confusion, or it's not clear. You're first taking the derivative with respect to x. That's this answer right here. Then you have to take the derivative of this with respect to y. What
Yeah.
is the derivative of this with respect to y?
Or
Well, 4x, yeah. And then this should also be 4x, okay? Well, how can that be? Well, here is the derivative of that with respect to y. Now you got to take the derivative of this thing I circled with respect to x. What's the derivative of 2x squared?
or
4x. These always match. There's no exceptions to that. They always match. All right, so as I mentioned, there were a couple of chain rule, product rule questions that we didn't really dive into. Um, we could do that, or we could go to some min-max problems. What would you like to do?
yeah, we can do one of those and then some min max.
Okay. I'm grabbing 16. I'll point out that I'm not plugging the numbers in, and for some of them, like this, there are going to be many times where it's undefined because there's some division by 0, but
Mhm.
you'll see that in your calculator. But that's that's not really a skill that you're probably struggling with. It's probably just taking the derivative. So it's always good to rewrite these as 6xy plus 1 to the minus 3 power, to write it. This is called inline without the denominator. So the derivative with respect to x, this is what I meant by a chain rule question, because you first have to apply the power rule and then the chain rule derivative of the inside part. Okay, so like this could be unclear, but if this was x plus 1, ignore the y, you would know to bring that minus 3 in front, and then minus 3 goes to minus 4, and then you have to take the derivative of the inside part. So if you can get to here, the derivative of the inside part is just what's the derivative of x? Well, the derivative of x is 1, but there's this y that goes along with it, so there's a y here on the outside. So this cleans up a little bit if you wanted to. Minus 18y over xy plus 1 to the 4th power. So now we're going to do the same thing, though. We're going to do it with respect to y. And it's very similar. It's since y is in the inside part of the function, it's still power rule followed by the chain rule derivative, which means the inside part. You have to take the derivative, keep going of the inside until you get that. So it's minus 3 times 6 xy plus 1 to the minus 4 power. Now the derivative of this with respect to y, the derivative of y is 1, so you just keep the x. So see, it's really similar. So this is one of those problems where if you pay attention to what is changing, the only numbers that's changing is this and this, which corresponds to this and this right here. Everything else will be exactly the same, meaning like this number goes down by 1, you bring that number out in front, and whatever your multiplier is there. Like there's a way to map this into the answers on the exam if you take the time to do that. Okay, let's look at some min-max problems here. You are allowed to use your graphing calculator, is that right?
Yes.
Okay. All right, so this is like this is part of the lesson here where I really can't show you how to do this in your graphing calculator. I can just talk about what you would do. We would assume most of the time that there is an optimal solution to doing these problems. So when you have a max problem, what you're looking for, it's called a bounded region. And that means that whatever you get when everything kind of works out here is you have to get a closed region like this for a max problem. For a min problem, you have an unbounded region, and that generally looks something like this, where it's like this, and your region is all of this stuff out here. And generally you're looking for these corner points, and that's what you're using to try to figure out whether there is a solution or not. So since it's the equation of two lines, you're almost always going to find the intersection of them. So you're always going to find the intersection. That's going to be one thing you're going to do. You're always going to find the intercepts. Okay. So there's a lot that goes into this. When I graph it using Desmos, I get this nice picture that you don't get with your graphing calculator, but you have to be able to find those points here. So like, for example, x plus y less than or equal to 13. When x is 0, y is 13 over 4. So somewhere over here, this is 13 over 4. And when y is 0, x is 13. So that's way out here. So that's this point right here. Oops, 13 comma 0. Okay. And then this other one is, well, when x is 0, y is 9. So that's up here. And when y is 0, x is like 2/3. Well, I keep putting those backwards, 2/3 comma 0. And then this greater than 0 gives you this point here. So we have kind of these are the edge points that we need. This one is actually not important because they're not in that region there. And then you have the 0, 0 region. So you have to find these intercepts, the ones that matter, because the ones over here don't matter. And then you need to find this point here through solving for the intersection of the system. If you do graph the lines, you can use the second calc intersect for that. You can also use matrices to solve for it. Your instructor probably doesn't care how you solve for it, but you have to get that point there.
So can I just graph it?
Yes. But it's very hard to graph those less than or equal to, so you would just turn them into equalities. So this point right here ends up being 1 comma 3. Okay, so if you're graphing it, that you're definitely going to want to get comfortable doing that. I want to talk about what you're going to do once you find these points, because you only get one submission on your exam. What I would do is I would first check that the point is correct. Okay, and how do you do that? Well, you have to make a little table. You have to you have to take your xy pairs and your p, which equals x plus 2y in this problem, and and you have to plug those in. So like 0, 0, 0 comma 13 over 4, 1 comma 3, and then the last one was like 2/3 comma 0. I had to figure out which one is the best here. So this is 0, obviously. The second one is 2 times 13 over 4, so that's 13 halves. That's looking pretty good. The next one is 1 plus 6, that's 7. Ooh, so this ends up being 6.5. So there's your winner for your max there. So what I would do first is I would check the ordered pair, make sure it's correct, and then put that into there. That way, if it's wrong, you can go back and check your calculations or see what you did wrong, and that way you're not giving yourself the chance to miss both of them on here. Um, were you able to graph it and get some of this
Yeah,
picture? Okay,
I'm feeling.
it's a huge hassle.
Yeah, I got 1 and 3.
Yeah, and the thing is it was almost this point, so it's not good enough to always believe that it's this point. A lot of times it is, but not always. And then you're like, man, I wish I had just spent a little more time. Probably though, it's always this point for this problem, but I wouldn't take that chance on a test,
So
I
what's
guess.
P?
So P is 7. It's taking that point and putting those ordered pairs back into uh, the
Oh,
optimization thing.
okay, got it.
All right, let's do number 8. It's very similar. I still can't believe they had you do these problems with 3, 4, 5 variables, and then like, hey, we're not going to test you. And you're like,
Yeah.
why did you have us even start? Okay, so the graph here roughly, and this is this is, you got to be able to do this in your calculator. I'm just putting like 0 in for x. That makes y 4.5. So 4.5, 0 comma 4.5. When y is 0, x is 4 point, I'm sorry, when y is 0, x is 9. So that's this one here. And then when this next equation, when x is 0, y is 9. So that's up here. And then when x is 0, y is, I'm sorry, when y is 0, x is 4.5. So you see you get 4.5 comma 0. You get these two corner points, and you get the origin, but
Mhm.
we need that one. That one comes from the intersection of the two. Now it could be the place where min or max is, but we
Yep,
don't
three
know.
and three.
That seems pretty reasonable there. So 3 comma 3. So now we don't know which one is right, and it usually is this point, but not always. So you make your table x comma y, p equals x plus y, and you'll see here, okay, 0 comma 4.5. Well, that's 4.5. I'm just adding two values, 3 comma 3, 6, 4.5 comma 0 is 4.5. Now, as a reminder, these are excluded because the overlap would only occur in this region here. And that's why those are excluded. So your maximum is 6 at 3 comma 3 for this one.
Mhm.
Okay, we'll do this min problem. So based on what I'm seeing, you're going to want to spend more time on the derivative stuff. These do look like all you do is solve for the intersection and figure out which one gives you the min or maximum value. So this is minimum, minimize, x plus 5y. So again, when x is 0, y is like 1.2 ish. Well, that's not right. It's 6 over. Yeah, it is 1.2. 6 over 5. And then over here it's 6 comma 0. And then there's a similar, notice these equations are exactly opposite here. So this ends up being 6 over 5 comma 0. And then this is up here, it's 0 comma 6. Because of the way the directions are going, your region's actually out here. So we need the intersection, but we don't need these points. But we need the intersection now. We need to figure out where they.
I got 1 and 1.
Yeah, that sounds pretty reasonable. So now, which one gives you the smallest value? You're choosing between this point, and this point, and it looks like it's where they intersect. I can't. I mean, it could be that simple on your test where it's just the place where they come together. I'm not sure. I would ask, say, are these really representative of my exam?
Mhm.
Out of 22 questions, 3 are optimization. We did them all. Out of 22 questions, 3 are these min-max problems, and 19 are your derivative problems. I would want to know, like, Mr. Instructor, is this what I should expect? Because it seems like there's not very many of those, and mostly some of these. All right, well, this is a great place for us to stop. I'll send the notes and the screen recording out shortly. Definitely be available to help you again if you need it before the exam, and thanks again for scheduling.
Okay, thank you.
See you next time. Bye now.